All right, today we're going to talk about trigonometric functions of any angle. Let theta be an angle in standard position and let the point P, x, comma, y be any point on the terminal side of theta. Let r equal the distance from the origin. So if we have some of the information that we're trying to solve for a certain side, we can use the Pythagorean theorem. So we know that x squared plus y squared is equal to r squared in this case, because r is the hypotenuse. So we can also use our right triangle trig to solve for the sine, cosine, and tangent of theta. So we know sine of theta is equal to the opposite over the hypotenuse, so in this case y over r. Cosine is equal to the adjacent over hypotenuse, so x over r. And tangent's equal to opposite over the adjacent, so y over x. That means then we're going to be learning about the cosecant, secant, and cotangent. So cosecant is reciprocal for the sine, and secant is reciprocal for cosine. So be careful with those because a lot of times students try to put sine and secant together because of s and s, which is not true. So cosecant is r over y, secant is then r over x, and cotangent is reciprocal for tangent, which is then x over y in this case. And of course, r can't be 0, x can't be 0, y cannot be equal to 0 because we can't divide by 0. So because the cosecant, secant, and cotangent ratios are reciprocal of sine, cosine, and tangent, they are called reciprocal functions. So cosecant theta is equal to then, if we think about the unit circle and r being equal to 1, then it would be equal to 1 over the sine of theta. Secant is 1 over the cosine of theta, cotangent is 1 over the tangent of theta. Similarly, we can do this with sine. So we could say the sine of theta equals 1 over the cosecant of theta. Then cosine of theta equals 1 over the sine of theta. And the tangent of theta equals 1 over the cotangent of theta. Also, because we learned about our unit circle and x being the cosine and y being the sine, remember we said at this point we could say that x is the cosine of theta comma the sine of theta. So if this is thinking about the unit circle when r is equal to 1, then remember we said tangent is also equal to the sine of the angle theta over the cosine of theta. And cotangent then would be the cosine of the angle over the sine of the angle. So these down here, the ones we just wrote, those are actually called quotient identities. And then the ones below are the reciprocal identities that we use. So we're going to use these to help us answer or find trig functions of any angle. Note that P can be any point on the terminal side of the angle except for the origin, since different choices of P generate similar triangles. Thus, the values of trigonometric ratio depend only on the angle. And whenever you're making your triangle, always make it with the x-axis. So depending on what side of the y-axis you're on, so if you're on the positive side, you're going to use the positive x-axis. If you're on the negative side, use the negative x-axis to make your triangle. So it says for this next example, let P, the point 6, 8, and the point 3, 4 be on the terminal side of theta. Find the sine, cosine, and tangent of theta. So if we first look at the point 3, 4, that would make this triangle right here. So I'm just going to go ahead and draw my triangle right here. So x is 3 and y is 4, and this is our angle theta here. So we need to solve for the r value or the hypotenuse. So in this case, we know r squared equals 3 squared plus 4 squared. So that tells us that r squared is equal to 25. And of course, the square root of 25 is 5. And so because we're in the first quadrant, we're using the positive answer for r. If you're in different quadrants, you have to be careful depending on what you're solving for. But r, since it's a hypotenuse, will always be positive. We don't ever use a negative distance for r. So sine is going to be equal to the opposite of the angle, so which is 4, over the hypotenuse, which is, we know, 5. Cosine is the adjacent of the angle, so 3 over the hypotenuse, which is 5. And tangent is equal to the opposite, 4 over the adjacent, which is 3. So those would be our trig ratios for the point 3, 4. So if we have the point then 6, 8, so we're going over 6 and up 8, so it makes this triangle right here. So if I draw my triangle theta, this is now 6 and this is 8, and we have to solve again for r. So r squared equals 6 squared plus 8 squared, so 36 plus 64 is 100. And so that means r is equal to 10. So the sine of theta would be equal to the opposite over hypotenuse, so 8 over 10, which of course you always want to reduce if equal to 4/5. Cosine of the angle is adjacent over the hypotenuse, which then if you reduce gives us 3/5. And the tangent would be opposite over adjacent, which is 8 over 6, which of course equals 4/3. And notice that because we are using the same angle for theta for both triangles, that it doesn't matter how long your r is, you're going to generate similar trig ratios for the same given angle. So that's what the whole point of this is. That's why we like to use the unit circle, because when we use those special right triangles, it always reduces to some trig function that is on your unit circle, which makes it really nice to use. So I got my calculator out, so we can also, it didn't ask us to do this in the question, but we can figure out what the angle is equal to by doing the inverse trig. So if I want to solve the sine of theta equals 4/5, to get theta out, remember we use inverse trig, which we learned in math 2, we did in math 3, so theta would be equal to the sine inverse of 4/5. So if I go to my mode first, I would want to make sure that I'm in degree mode, which you'd have to go to mode and then scroll down and hit enter on degree, because every time you clear your calculator, remember, it always defaults back to radian. So now when I go to my home screen, we have second sine gives us a sine inverse 4 divided by 5, which gives us theta being equal to 53.13, or I'll just put 53.1 degrees. Now, did I have to use the sine inverse? No, I could do the cosine inverse and 3/5. And notice I get the same answer, or I could have used the tangent inverse and 4/3, and I would get the same thing. So just to show you, it doesn't matter which one you choose because it gives you the same angle that we're using for this. We want to look at the point -6, -2. So the point -6, -2, of course, if it's negative x and negative y, this tells me that we are going to be in quadrant 3. So, and again, the quadrants are 1, 2, 3, 4, in case you forget. So then when I draw my triangle, it's going to go this way, and this would be my angle of theta. X is -6 and y is -2. So we want to solve for r using the Pythagorean theorem. So r squared equals -2 squared plus -6 squared. So r squared is equal to 36 plus 4, which is 40. So r equals the square root of 40, which we want to reduce. So 40 breaks down into 4, 10. So 2 root 10, because this makes a group of 2, but this one doesn't. So this is equal to 2 roots 10 when we simplify. So let's go ahead and put that on our triangle here. So this would be 2 roots 10. And now I can find the sine. So sine is the opposite over the hypotenuse. So -2 over 2 roots 10. So the 2's, because they're not underneath the radical, we can simplify. This is -1 over root 10. And then we don't like to have radicals in our denominator, so you'd want to rationalize that by multiplying by roots 10 over root 10. So this is equal to -roots 10 over 10. Cosine is the adjacent over the hypotenuse, so the adjacent is -6 over 2 roots 10. Again, we can simplify -6 in the 2, gives us -3 over the square root of 10, and then we have to rationalize that. And then when we do that, we get -3 roots 10 over 10. Looking at the tangent, so for the tangent, we have the opposite of the angle over the adjacent of the angle, so -2 over -6, which is just equal to +1/3. So cotangent is easy because we just need to flip that from the tangent. So 3 over 1, which is just equal to 3. So for secant and cosecant, I'm going to use the answer from the beginning, right? Or well, actually, we should use the one where we got simplified it. So this right here. So if I flip this, that's actually what the cosecant's equal to. So that would give me negative roots 10 over 1, which is just negative roots 10. Now, can you flip your answer here? Sure. So if I flip that answer, that's fine. You just would have to rationalize your denominator again. So it gives you the same answer in the end. So if I multiply this by root 10 over root 10, notice I would get 10 root 10 over 10. So it simplifies into negative root 10. It's just more work. So that's why I decided to use this one here. So same thing for secant. So this one would be the best to use to flip because I don't have to rationalize the denominator again. So this would be negative root 10 over 3. So now I have my 6 trig functions. So next thing we're going to take a look at is the signs of trig functions. So depending on the location of the terminal side of the angle, trigonometric functions can be positive, negative, or negative. Using your knowledge of trig function values, identify the functions that are positive in each quadrant. So remember, this is quadrant 1, 2, 3, and 4. And so it depends on the sign. So remember, this is in the first quadrant, x is positive and y is positive. In the second quadrant, x is negative and y is positive. The third quadrant, we have negative, negative, and in the fourth quadrant, positive, negative. So in the first quadrant, because your x and y is positive, because if remember, if we go back to our circle up here, we're thinking about this right here. So if x and y is positive, and we know that our hypotenuse is always positive, that means that all trig functions would be positive in the first quadrant. So all trig functions. So normally we put an A there to stand for all. And then in the second quadrant, x is cosine and y is sine. So that means that my x is negative, so my cosine is negative, but my sine is positive. So in quadrant 2, sine is going to be positive and its reciprocal function, which is cosecant. So that means in this one, we're going to use S for the letter to stand for sine and its reciprocal. Quadrant 3, both are negative, both x and y, so cosine's negative, sine's negative, but tangents, remember, sine over cosine. So if you divide a negative by a negative, you get positive. So that means that in quadrant 3, the tangent and its reciprocal cotangent are positive. So I'm going to put a T for tangent. And in quadrant 4, notice that your cosine's positive, but your sine is negative, and that means your tangent would also be negative because you're dividing sine over cosine, so negative divided by positive is negative. So for this one, we would have cosine and its reciprocal secant. So I'm going to put a C. So the way to remember that is we say all students take calculus, and notice we're going to order the quadrants when we go around. So that's how you can remember all trig functions, sine and its reciprocal, tangent and its reciprocal, and cosine and its reciprocal. So if cosine theta is greater than 0, which quadrants could the terminal side of theta lie? So when cosine is greater than 0, that means that our x value is positive. So where is our x value positive? It's positive in quadrant 1 and quadrant 4. If tangent is less than 0, which quadrant could the terminal side of theta lie? So tangent, remember, is your sine over cosine. So for this one, we're looking at we have to have one positive, one negative. So where is sine negative and your cosine negative? So here, notice that we're negative in quadrants 2 and quadrant 4. We can't use quadrant 3 because when you divide sine over cosine, you would end up with a positive. So quadrants 2 and 4. And then this one says if secant is less than 0, which quadrants could the terminal side lie in? So remember, secant is the reciprocal for cosine. So we're also saying, where's the cosine of theta less than 0? So cosine is our x value. So we want our x value to be negative. So x is negative in quadrants 2 and also quadrant 3. And if sine is less than 0, so that means if our y value is negative, and cotangent is greater than 0, so if cotangent is greater than 0, then that means we need to have either the first quadrant or in the third quadrant, but since y is negative, we're going to be using quadrant 3. So that is how we use the all students take calculus and like. All right, so use again given information to find the exact values of the 5 remaining trig functions of theta. So looking at the first one, so I'm just going to rewrite up here. All students take calculus to help me figure out the quadrants, and we have SOHCAHTOA, if it helps you to remember how to do the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent opposite over adjacent. So for this first one, we have the sine of theta equals 8 over 17, which is positive, and tangent is less than 0. So we have to think about where's the sine positive in quadrants 1 and quadrants 2, but where's the tangent less than 0? The tangent is positive in quadrants 1 and 3. So what satisfies the sine of the angle being greater than 0, but the tangent of the angle being less than 0? We know that we would have to be in quadrant 2. So when I draw my triangle, I'm going to draw my triangle in quadrant 2. So sine is equal to the opposite, which is 8, over the hypotenuse, which is 17. So we need to figure out what our x side length is, I'm going to call it. So to find x, we use our Pythagorean theorem. So the hypotenuse squared equals 8 squared plus x squared in this case. So 289 equals 64 plus x squared. So 225 equals x squared. So 15 is equal to x. Now you have to be careful here because we are in quadrant 2. The sign is negative. So remember, whenever you take away an even power, it's plus or minus the square root. And since we're not working with the hypotenuse, we can make this negative. So we're actually going to use this x value as negative 15 because we're in quadrant 2. So the cosine is the adjacent over the hypotenuse. So negative 15 over 17, which means then if we know cosine, we can flip that to get the secant. So the secant would be negative 17 over 15, because remember, those are reciprocals. The tangent is equal to the opposite over the adjacent, so 8 over negative 15. And that means that we know what the cotangent is because those are reciprocal. So cotangent would be negative 15 over 8. And then cosecant's reciprocal for sine. So if sine is 8 over 17, that means this is 17 over 8. And that would be all of our trig functions. So the hardest part was just figuring out what quadrant we're going to draw our triangle in, and then also remembering that our x is negative in this quadrant. So looking at the next problem, for this one, the same thing. We have to figure out what quadrant we're in. So cotangent is negative, and the secant is greater than 0. So remember, cotangent means that tangent of the angle would also be less than 0. And secant is reciprocal for cosine, so this is saying the cosine of the angle is greater than 0. So again, if we think about all students take calculus, we're trying to figure out where is the tangent and cotangent negative, but the cosine's positive. So cosine's positive in quadrant 1 and quadrant 4. And tangent's also positive in quadrant 1, so that means we're using quadrant 4 here. So this would be the quadrant we would want. So when we set up our triangle, it would look like this. So cotangent, remember, is reciprocal for tangent. So we can say that for this one, the cotangent of the angle equals 1 over the tangent of theta. So if the cotangent of theta is equal to negative 4, then tangent would be 1 over negative 4. So we can use that to then put our side lengths on. So tangent, we know, is the opposite over adjacent. So notice the negative 4 here is here, but if you do opposite over adjacent, because we're in quadrant 4, you know your x isn't negative. So maybe it would be better to write the negative just in front when that happens, so that you don't assume that it goes with the 4. So this would be positive 4, and this is negative 1, because that's, you have to just think about what quadrant you're in to figure out which one's positive and which one's going to be negative for the side length. And this is r. So r squared equals 4 squared plus negative 1 squared. So 16 plus 1 is 17, so r squared equals 17. So r equals the square root of 17, which doesn't reduce. So that I can go ahead and write that here if it helps. So then we want the sine of the angle. Sine is opposite over the hypotenuse. So -1 over root 17, which we don't like to have radicals in our denominator. So we're going to rationalize that. I multiply by root 17 over root 17 because that doesn't change my equation. So we have negative root 17 over 17. For the next one, the cosine of the angle adjacent over hypotenuse. So if I do the adjacent over the hypotenuse, and then I have to rationalize, I get 4 root 17 over 17. And notice that the cosine is positive. So if I know cosine and sine, I know cosecant and secant. So we know that the sine is reciprocal for cosecant. So I'm going to flip my original one so I don't have to rationalize again. So then for this one, the cosecant is equal to negative root 17. And then for cosine being the reciprocal of secant, I'm going to again flip this one right here so I don't have to rationalize again. So this would be root 17 over 4. And then for tangent, tangent we already know because we did that in the beginning is equal to -1/4. And that would be it. So looking at the next one, we have the cosecant of theta is negative. So cosecant's reciprocal for sine. So that means where is the sine of the angle going to be less than 0? And the cosine of the angle is also less than 0. So all students take calculus. We know it can't be in the first quadrant. And we want sine to be negative, so can't be in the second quadrant. And we also want cosine to be negative, so it can't be this quadrant here. It has to be in the third quadrant. So this is the one we're going to use. So we're going to draw our triangle in quadrant 3. So cosecant is reciprocal for the sine. So if we flip this, we get the sine of theta is going to be equal to -2 over root 5. So I'm going to use that to help me draw my triangle before I rationalize it. So sine is equal to the opposite over the hypotenuse. Now remember, the hypotenuse is always positive length from the origin to the point. So that means that the negative, because this is in quadrant 3, has to go with the y value. So for this, then, when we rationalize for this value, we have -2 over root 5, and then multiply that by root 5 over root 5. We get -2 root 5 over 5. And then we went to, oops, I forgot, solve for our x as well to do cosine. So then root 5 squared, because that's a hypotenuse, equals -2 squared plus x squared. So root 5 squared is just 5 equals 4 plus x squared. So 1 is equal to x squared. So -1 is equal to x because, again, since we are in the third quadrant, x has to be negative. So cosine is equal to -1 over root 5 because it's the adjacent over hypotenuse. And then rationalize that. And when we rationalize, we get -root 5 over 5. You don't really need that one placeholder, so you can just write it like this. Tangent is equal to opposite over the adjacent, so -2 over -1, which is just 2. And then secant is the reciprocal for cosine. So I'm going to flip this value right here so I don't have to rationalize again, so -root 5. And then, of course, cotangent is the reciprocal for tangent. So this would be 1/2. And that gives us all our trig ratios. All right, so for these next examples, we're looking at finding the exact values of the following using the unit circle. So no calculator, of course, on these types of problems because we're just thinking about our unit circle values. So 4 pi over 3, remember, is in quadrant 3 on our unit circle, but this is cosecant of 4 pi over 3. So 4 pi over 3 on the unit circle would be down here. So remember, cosecant is reciprocal for sine, so we know that the cosecant of the angle is equal to 1 over the sine of the angle, and in this case, the angle is 4 pi over 3. So the cosecant of 4 pi over 3 is equal to 1 over the sine of 4 pi over 3. So we just need to figure out what is the sine of 4 pi over 3. So sine is the y coordinate on our unit circle. So at this point here at 4 pi over 3, recall it's negative root 3 over 2. So we have 1 over negative root 3 over 2. And then we're really just flipping this. So remember, when you divide a fraction by fraction, keep, change, flip. So this, because it's 1, would just end up being negative 2 over root 3. And then we want to, of course, rationalize our denominator whenever we have a radical in it. So multiplied by root 3 over root 3. So when we multiply the numerator and denominator by root 3 over root 3, we end up with negative 2 root 3 over 3. So the cosecant of 4 pi over 3 equals negative 2 root 3 over 3. The secant is reciprocal for the cosine, so the secant of the angle. So the secant of 17 pi over 6 equals 1 over the cosine of 17 pi over 6. And so this is coterminal with an angle on our unit circle, so we need to figure out what that coterminal angle is. So remember, to find coterminal angles, we add or subtract 2 pi. In this case, we're going to subtract the 2 pi, which means we need a common denominator. So this would give us 17 pi over 6 minus 12 pi over 6, which then gives us 5 pi over 6. So that means this is also equal to 1 over the cosine of 5 pi over 6. So thinking about where's the cosine of 5 pi over 6, that's in quadrant 2 right here on our unit circle. Cosine's the x value, and so x is negative here, so negative root 3 over 2. So this is 1 over negative root 3 over 2, which we just did over here. So that means that this is also going to be equal to negative 2 root 3 over 3 when you do your keep, change, flip, and rationalize. Next, we have the cotangent of negative 11 pi over 4, which is reciprocal for tangent. So the cotangent of negative 11 pi over 4 is equal to 1 over the tangent of negative 11 pi over 4, which is coterminal with an angle on our unit circle. So we're going to find that angle first. So negative 11 pi over 4 plus 2 pi. We need a common denominator, so multiply this by 4 over 4. So that gives us 8 pi over 4. So negative 11 pi over 4 plus 8 pi over 4, which gives us negative 3 pi over 4. So that's still negative. So if you don't know where that's at, you can add another 8 pi over 4, which is adding another 2 pi to find the coterminal angle. So that is going to give us 5 pi over 4 from our unit circle. So this is equal to 1 over the tangent of 5 pi over 4. So you have to think then, where's the tangent of 5 pi over 4? So notice the numerator is 1 more than denominator, so now it's going to be in this quadrant in the middle. So tangent, remember, all students take calculus, is positive in this quadrant. And so then for this one, if it's the middle one, that's cosine and sine are both the same value, root 2 over 2, root 2 over 2 negative. So that means this is 1. So we get 1 over 1, which is just equal to 1 for this value. And if it helps you to write out your tangent values from quadrant 1, that's a good idea. So the tangent of 0 is 0. Remember that the tangent of pi over 6 is root 3 over 3. The tangent of pi over 4 is 1. And the tangent of pi over 3 is root 3. And pi over 2 is undefined. And so we're just taking this value and putting it over here, remember, because tangent as origin symmetry. So then for looking at the last one, tangent of negative 390 degrees. So we're going to find the coterminal angle. So 360, if we add that to negative 390, we get negative 30 degrees. So add another 360 degrees to get 330 degrees. So the tangent of negative 390 is equal to the tangent of 330 degrees. So 330 degrees would be right here on my circle, which is going to be using this reference triangle of the root 3 over 3, but it's in the fourth quadrant, which means that it's going to be negative root 3 over 3, because again, all students take calculus, so tangent is negative in this quadrant. So that gives us our values from our unit circle. And then next we're going to look at solving trig equations. So in the previous examples, we are given the value of theta and asked to find the corresponding trigonometric ratio. We can also solve problems that are inverses of these, where we are given the trig ratio and we are asked to find the corresponding values of theta. So solving equations using the unit circle, solutions to sine theta equals some number are symmetric about the y-axis. So remember, sine's positive here and here, and negative down in these two quadrants. And then looking at the next one, cosine are symmetric about the x-axis. So that means these answers are going to generate the same solutions. And if it's negative, it would be on this side, wherever you are in your unit circle. And tangent solutions are symmetric about the origin. So that means that this answer and this answer are going to be the same because they're tangent. Again, remember, all students take calculus as positive in first quadrant and also the third quadrant. So it says, solve each equation for all values of theta from 0 to 2 pi, and not including 2 pi in this case. So for this, remember, when you're solving for an angle, you're just trying to figure out, in this case, from your unit circle, the sine of what angle gives us a y value of 1/2. The sine is the y coordinate. So remember, where do we get a y value of 1/2? That's positive for sine. That is positive here in the first quadrant and also in the second quadrant. So that would be theta equals pi over 6 and 5 pi over 6. Then for the next one, we have the cosine is equal to negative root 3 over 2. So where's cosine negative? Quadrants 2 and quadrant 3. So negative root 3 over 2 would be here and here on our unit circle. So theta is equal to 5 pi over 6 and 7 pi over 6 from our unit circle. The next one is tangent equal to -1. So tangent is negative in quadrant 2 and quadrant 4. Remember, the 1 would be in the middle at the over 4. So 3 pi over 4 and 7 pi over 4 for the quadrant 4. And then where's the cosine equal to 0? So cosine is the x-coordinate. Where's the x-coordinate 0? The x-coordinate 0 here and here. So at pi over 2 and 3 pi over 2. And then secant is reciprocal for cosine. So that would be then the cosine of the angle is going to be equal to the reciprocal of this. So this would be 3 over 2 root 3. And then you'd want to rationalize that, which then gives us 3 root 3 over, this times this would be 3. So 3 times 2 is 6, which reduces into root 3 over 2. So we're looking for, where is the cosine equal to positive root 3 over 2? Quadrants 1 and 4. So that would be here and here on our circle. So theta equals pi over 6 and 11 pi over 6. And then cosecant equal -1. Cosecant is reciprocal for sine. So that's the sine of the angle would then be equal to 1 over -1, which is just -1. So on our circle, where is the sine equal to -1? That's the y coordinate. That would be down here at 3 pi over 2. And remember, sine only has one answer for where it's equal to -1 for our unit circle. So we don't actually have two answers in this one. So that is it for solving our trig equations.